All right, so simplifying rational expressions. Here we are. Fraction expressions. The r squared minus 20, r plus 100 over r minus 10. All right, you got a variable. So it's like a fraction, okay? So what does this say for us to do? State the excluded values for each. So what does that mean exactly? Well, it means this. For number 1, r can be any number. Right? R could be any number, but there's one number that it cannot be. It cannot be one number. It could be 2, it could be 5, it could be 6, it could be 9.8467. But there's one magic number it can't be. And it has to do with the fact that 1 divided by 0 does not exist. So if you do 1 divided by 0 or any number divided by 0, it does not exist. It's not a number. So for number 1 and the rest, or just for number 1, if the bottom ever becomes 0 with whatever r you put in, then the fact is r can never be that number. So what makes the bottom 0? What r makes the bottom 0? What r you...
R is a letter, not a number.
Yeah, well, r represents a missing number, an unknown number. And we're trying to find what r will make the bottom.
Oh, you see, Matt? I don't know where the hell went it.
Well, r cannot be 10. Why? Because if you replace r with 10, meaning if you say r is 10, you'll plug it in on the top right. 10 squared minus 20 times r plus 100, you get something. But on the bottom, what happens?
Oh, it'd be 10 minus 10.
10 minus 10.
And that'll be 0.
And be 0.
You can't do that.
Exactly. R cannot be 10. Why? Because 1 divided by 0, or any number divided by 0, does not exist. Simple as that. So when they say state the excluded values for each, r cannot be 10, well, 10 is the answer. R not 10, r does not equal 10, equal with the cross.
That's the answer?
That's the answer. 10 is the answer. Because it could not be an answer for that. R. Get it? Blow your mind?
Not really.
I think you do.
So we're like kind of.
Can you do number...
It's not the answer.
Pretty much. So state
The number 2.
number 2. Let's do it. So again, here's a rational expression. B is an unknown number. It could be anything, but there is one number it cannot be. And in this case, you'll find there's actually 2 numbers that it cannot be. It can be any other number. So how are we going to do that? Well, we don't really care about the top. What makes the top 0? We don't care about that because 0 divided by 1 or any number is just 0. That's a real number. That's okay. But this does not exist. No existo. 1 divided by 0. Okay, so what makes the bottom 0? What b's, if you plug it into the bottom, will make that 0? Well, it's not so clear right now. So that's the magic of factoring. So let's factor the bottom. And this is what we did yesterday's test. Factor the bottom. We'll put 9 on top, 6 on the bottom. Let's multiply to 9, 2 numbers, and add to 6, 3 and 3.
Yes.
So the factorization on the bottom is b plus 3, b plus 3. So what b would make the bottom 0?
Negative 3.
-3. So b cannot equal -3. And what I said before is that there are 2 numbers. Is there actually a second number in this case?
No.
Because b plus 3 repeated as another factor. That doesn't happen all the time, but sometimes it does. But if b plus it was b plus something else or minus something else on their side, we'd find another number it cannot equal. So b cannot equal 3. Because this whole entire expression, so you go back to the beginning, if you replace b with negative or with -3, you'll get 0 on top, and then you get 0 on the bottom. 0 divided by 0 does not exist. So we exclude -3. All right, I think we got it. Let me see if there's anything else to do. Special.
Taxes.
Yeah, no, refuse them.
Do number...
Could you do a simplified one?
The simple. Oh, the one at the bottom, right?
Yes, sir.
Um,
Anyone is.
and just looking through them,
I still don't know what you just did on number 2.
What are you talking?
you'll figure it out.
You're just trying to make the bottom equal 0. Basically.
How to
Because he.
Alright. got it.
All right, number
You gotta
3
put
and
the
5.
number into that letter to make it equal 0.
Number 3 and 5 are different to me because this is not like the X game factoring because there's that 3 terms on the bottom. That's the GCF factoring. See what you can pull out. You can divide out a V, and you can divide out like a 8 or something, and then see what. Honestly, let's just do 3 together. So 16 V cubed on the top. We don't really care what's going on at the top. You don't need to factor the top, even if that was factorable. That's not factorable. That's already as it is. But the bottom, you got something that could be factored because there's more than one term. So it looks like you can pull out a V from the 2 and also an 8. So I divide out 8V. What's left inside the parentheses?
12.
Well, 24 divided by 8. What's left inside?
I have no idea.
4. And we only took out one V. So 4V plus 2. See, we divided out 8V, put it in front. And if we divide it out, what's left? It's this. So now the question is, what 2 V's, or what 1 V, or 2 V's? We exclude V equals 0. All right, so it's like you got 2 factors, okay? You can put parentheses. Okay, 8V. What makes 8V equals 0? Well, that's V equals 0. And then look at the other one. 4V plus 2 equals 0. What V makes that equal to the that equal to 0? It's negative 2 over 4, which is negative 1/2. So those are the 2 numbers V cannot be.
Okay, question, Thomas.
Yes.
So, you got the 8 from the 24, right?
Yes.
And you got the 4 and the 2 from 16?
Okay, no, I got 8 from the 24 and 16. I divided out 8 from 24. Once I divided, I left with 4 there. I divided 8 out of 16, I was left with 2.
Oh, okay.
I divided out from both so you can put it in front of the whole parentheses. Because distribution,
Wait, you divided 24 by 8.
24 divided by 8.
You got 4.
4. 16 divided by 8, left with 2. And so that 8 comes out, just like comes out and comes to the front.
24 divided by 8 is 3.
It's 3.
That's what I was confused. I was like, how you get 24, 8,
I don't know that.
4?
Okay, that looks better.
Well, boom, there we go. So the 2 numbers are actually those 2. All right, so let's do one of the simplify ones. All right, simplify each. Well, all that means is, actually, kind of important. Simplify each. It just means factor, then cross out, repeating factors. So what does that mean? So number 7, if I factor the top and factor the bottom. If I factor the top, factor the bottom, and I have, for example, so that example up there I wrote, it's really small, but this can be simplified. And notice it's in factor form. What can be simplified? In other words, what can be crossed out top and bottom?
X plus 2.
You see an x plus 2 on top and x plus 2 on the bottom? Yes. You can cross those out. and you're left with x plus 3, x minus 4. You see that simplifying. You got many numbers into less numbers. And the rule is if it's similar on the top and the bottom, you cross them out and rewrite the expression.
So we don't have to answer it or simplify it?
Nothing to answer, yeah, just simplify. See, it doesn't say find the excluding numbers or nothing like that. All right, so number 7, simplify. What can we cross out? Well, it's not in a state where you can cross numbers out right now. It has to be in factored form. So the top and the bottom do have to be factored. So the top factored, doing the X game method, I'm doing it in my head, is this. And the bottom factored, doing the X game method, I'm going to do it in my head. Hopefully I'm not wrong. Well, let me just set it up and then I'll think out loud. So I need to find two numbers that multiply to negative 20, but add to 8.
4 and 5.
4 and
Wait, no, never mind.
2 and 10. So minus 2 and plus 10. Ah, okay, so we factor the top, factor the bottom. Now can we simplify? Is there anything simplifiable? The x minus 2? So the simplified expression is x minus 1, x plus 10. Boom. That's the answer.
That's a little bit. This is like work. Wait. No, I'm just joshing. That's all. I don't get it.
So I think I'll stop there. Y'all work out the rest. I mean, it's all just, hey, I did this.
To get
Because-
this and this.
Well, no, it's just, there's nothing you're doing or understanding. It's just
It seems
Just-
easy. Like it's just
why and
something that I
stuff.
don't want to pick up. You know, I don't want to know this.
It's about just repeating that exact thing, but with different numbers. That's all it is. You don't need to understand it. What's the point of this? I mean, you know. Unless everything in math is like word problems, it's like, what's the point of this? You know, everything in math is word problems or actual like physical. Like, a lot of it is just, hey, I did this because this is stuff you can do, allowed to do, apparently. So just do that for other problems with different numbers. And it's about just the process and adapting the process for the numbers or letters or situations for the example you're on.
So, what kind of real life scenario you think you would